Hi everyone, my name is Nathan Moore. I am the director of the performance engineering team here at StackPath. StackPath, for those who may or may not know, is a very large global content delivery network. So we have a very large presence with just thousands and thousands of servers all throughout the world. Today's talk is about automating and augmenting our capacity planning. In other words, where do we need to put servers? How badly are our servers being used? How hard are they getting run? Where do we need to install new servers? And in order to do that, we have a tremendous amount of data that we collect about every single server, and we use that to build out a direct predictive model trying to tell us the answer to the question of where is it that we should put, where is it that we're running hot, where is it that we're running cold, where do we need more capacity, where can we get away with less capacity. So we have a global presence, and this means that we have about, 30 odd points of presence. Point of presence is called a POP. And as you can see from the map, they are properly globally distributed. Now, in every POP, we have a Prometheus instance. And that Prometheus instance is recording all the data that comes off of all the servers within that POP. So it's telling us a tremendous amount of hardware and serving statistics. It tells us the number of requests per second that the servers are running. It tells us all manner of information. So this kind of information includes the CPU utilization, disk utilization, active connections, and bandwidth served, in addition to the requests per second that that server is actually pushing out. Now, I want to be a little bit careful to comment that we have run a custom load balancer, and our goal of our custom load balancer is to do things like identify very popular objects. And if an object is very popular, then it must get served by multiple servers. We don't want it on just one. Whereas a less popular object, we can keep it only and make sure it only serves from one server as opposed to a bunch. But this means that our serving patterns are very distributed. They vary. Not every server is exactly the same as the other. It will have a different utilization profile than the server next to it. What we want to do is we want to take all this information and we want to use it to make a prediction. It's insufficient just to note that, oh, we have so many RPS at this given point in time. We want to know, well, how does that correlate with how the machine is doing? Because we know we are in a varied infrastructure. So Prometheus does come with this lovely built-in linear estimate function. And the ideal case is that we would be able to use Prometheus and keep all the logic in-house. And unfortunately, the way that the linear estimate function works is it predicts strictly against time. It does not allow us to predict against multiple vectors. It only allows us to predict a point in time given this one range vector. So for instance, if I was interested in the transactions per second for my disk, I can use the predict linear to say, given the past so many days worth of history, what is my likely disk transaction per second going to be tomorrow? And it will tell me that particular value. But unfortunately, this only goes across time. And what we want to do is correlate against CPU utilization, disk utilization, and so on. And so the predict linear function cannot do that. So instead of using the linear estimate function, we can take advantage of the data export capability of Prometheus, query it via API, and then export that into another program for further processing. So there's a couple things that we want to take advantage of here, which fortunately the API gives us. So in this particular case, I'm using the query range API, and you'll notice that independent of the query, I can specify my start time, my end time, and my step time. Now, what does this mean? If I make different queries, but every single time passing in the exact same start time, the same end time, and the same step, then what happens is the returned values are always taken at the exact same time interval. So if you look at the return JSON, that every single timestamp on there is going to be the exact same independent of my query because I have always specified the exact same start, end, and step. So because of that, I can use the timestamp as a key, and I can line up all of my values using the same exact timestamp as a key. What this means is that once I can do this, then all I have to do is write a new little script, which is going to make multiple API queries, one per range vector that I care about. Remember, I have at least 4 or 5 of them, like the disk TPS, active connections, bandwidth used, and CPU use. Every single one of those is an individual query. So I go ahead and I pull that out, extract via the JSON the timestamps, put them all back together by the common timestamp, and then export that all out via a comma-separated value file. Not a problem. What this in effect means is that I can now import this CSV file into a program like R for proper multivariate analysis. And so all that I'm asking R to do, I want it to clean the data set, create the actual linear regression model. But then, because I have this varied infrastructure, I want to look at the 99th percentile utilization numbers for all of my utilization numbers. Then I have to apply that to the linear regression and export out the results. And this gives me a predicted per server value, multiply that by the number of servers per POP, and all of a sudden I have that POP's capacity. And now I have a predictive model telling me how well I'm doing and what it is that I should expect.
Hello everybody, I'm Matthias Leube, software developer from Berlin, working for Red Hat, and I'm a Thanos maintainer working on Prometheus operator and Prometheus, for example. So first of all, you might know me from GitHub. So this is what I do. This is where you can find me. So feel free to reach out there. Obviously, you can also find me on Twitter /metalmatze. So that's like where you can find me if you have any questions on this talk. Today, I want to, as with the last PromCon, I want to talk about multi-burn rate alerts. And these are quite interesting because they allow us to alert on our SLOs in a very meaningful way, so that we kind of like take two error burn rates and combine them to reduce the noise and really make sure that we really only alert when there's actually something happening, which will reduce alert fatigue and allow us to really get the attention when necessary, and if not necessary, then we leave the people alone, because it's like not that big of a deal if there are like some errors happening every now and then, right? So from this website, you can see there are quite some things to consider implementing this. It's actually Prometheus alert, and actually at the last PromCon I already shown this. But I extended it a bit, and that's why I'm giving this talk. So at the last PromCon, I've shown this errors panel, and you can kind of say, I want to have this amount of unavailability or availability as a target, and you can define this here. So you can say, I want to have like 99.5% availability, and that would be 3 hours and 36 minutes unavailability in 30 days. And you want to alert on the metric HTTP request total. I often put in the Nginx controller requests total so that I kind of alert as early in the stack as possible on the load balancer, kind of so close to the user as possible, right? You can put in some selectors like ingress is app. And for the people who want some more advanced things, they can change the alert name, the alert message, and you can also, if you have status equals 500 instead of code equals 500, you can kind of override this here. But let's keep it simple, and we can generate this, and we can see, okay, we get all of these nice alerts right at the very top, and they kind of are based on top of these alerting rules, which are defined further down here. So what you can do is you can just copy the entire thing into your clipboard and then import them in Prometheus or put them into a Prometheus rule custom resource, and they will be loaded by Prometheus and then alerted on for your application. So that's very neat. The only thing missing, or like another thing missing that I wanted to add, is latency. So you might want to alert on too many errors, but you also want to alert if something is too slow, right? So in this case, we would alert on 99% of our requests should be faster than 100 milliseconds. So let's change it to 500 milliseconds for this example. And then again, using the HTTP request duration seconds, which you know from most Prometheus instrumented applications, You can change the same selectors. I've already shown that, and let's go ahead and generate this. It will generate a similar thing, but this time it will alert when the application is actually too slow overall in 28 days again. Hopefully this is quite helpful to you. The entire source is on GitHub. You can find it here on PromTools Dev, and this is building on top of the SLO libsonnet project, which is actually using JSONet to generate these recording rules on the fly. And that's all. Stay safe and hopefully see you soon. Bye-bye.
Right, thank you. Next up, we have Julian Pivotal talking about 5 better tips to use Prometheus service discovery.
Hello everyone. I will tell you 5 tips to better use the Prometheus service discovery mechanism. So first of all, what is service discovery in Prometheus? So service discovery in Prometheus is used to discover targets, which means that when you want to scrape your pods, your containers, your VMs, we will directly talk to the source of truth to actually discover which ones we should monitor. So there are 2 kinds of service discoveries, the ones which will listen to the source of truth all the time, like console, and when there is an update, console will tell Prometheus, hey, there is an update, and the other ones which will run every 30 seconds, every 1 minute. That is service discoveries in Prometheus. We have lots of examples like GCE, EC2, console, Kubernetes, DNS, etc. A classic example is like this, Prometheus will connect to a cloud provider, and then after that configuration, so this is for the node exporter, you will actually use what is called reliable configuration to actually tell Prometheus, hey, take the labels from the service discovery and alter them so I can use another address than the default one or add extra labels. In this case, we are taking the IPv6 instead of the IPv4 that we would get by default, and then we append an extra port to the configuration that we get from the cloud provider. So this is the classic pattern, service discovery and reliable configuration. The first tip is that the alert manager configurations, they are service discoveries, which means that you can automatically discover your alert managers. And you don't need to do the static configuration for them, which is kind of confusing because by default, the Prometheus, the YAML that we ship with Prometheus is actually telling only the static configuration. So you can use the same service discoveries for your alert managers. The second tip is that all the service discoveries are lists. So if you have multiple, in this case, DigitalOcean accounts, you can use all of them in the same job if you wish to. If you have multiple, Kubernetes cluster or namespace, you can also use multiple of them in the same service discovery configuration. So you are not bound to one job is one service discovery configuration. The third tip is the same, but it's also that you can have multiple kinds of service discoveries for one job. So you can, for example, in the same script configuration, have a static configuration and have a GC configuration and have a digital configuration as well. So you can mix multiple service discoveries into one job if you want to. The fourth tip is that you can reuse the service discoveries. So obviously you can do it, but if you do it like this, so in this case I have the DigitalOcean SD configs, which is bearer token and then my bearer token. If it is the same configuration exactly between multiple script jobs, it must be exactly the same, then Prometheus will actually reuse them in the background. So instead of querying the API twice because it is in 2 different jobs, it will only query the API once, which will be very effective and it will not overload your source of truth with multiple requests. To see that it is actually working, you need to enable the debug logs, and then you will get a line, and at the end of the line you will see discovery manager scripts, starting provider, and then you have the subs, which are the jobs for which this service provider will be actually used. So in this case we see subs equal node and cAdvisor. And the last tip I want to tell you is that the file SD, so which is the generic service discovery in Prometheus, it can contain configuration labels. So this is basically the Prometheus configuration, and then you can have targets.yaml files, for example, or JSON files, but you can then include the special labels that you can have. You can check the Prometheus configuration, but you can like change the scheme, change the metrics path, and change the HTTP parameters, for example, individually for each target or each target group that you want. So with this single file, I am able to configure an HTTPS target with /metrics2 instead of /metrics and foo equal bar, and then a second one which will have foo equal bar 2, but we still use the default HTTP and the default /metrics endpoint. So those were my 5 tips for you for service discoveries. Thank you for listening. Bye.
Okay, thank you, Julian. The next talk, which I kind of hinted at in one of the breakout sessions yesterday, is on Prometheus in the OR ecosystem by Aaron Jacobs, which might also be a little useful when looking at Nathan's talk, which is the first one he gave, because he also used OR.
Hi, my name is Aaron Jacobs, and I'm going to be talking about Prometheus in the R ecosystem, which I think would probably be a topic not many participants will know that much about. So I should say I'm a data scientist based in Toronto, and I work at Crescendo, which is a company that sort of provides back-end technology services, lots of them related to statistical modeling to online sports books, which take wagers on sports. And I should say, relevant to this conference, most of my experience with Prometheus is fairly recent. In the last 6 months, my organization's been transitioning to Kubernetes, and I've been working a lot on adding instrumentation to our applications, both in R and also actually in C#, in order to sort of leverage this platform a lot better. If you want, you can find me on GitHub and also on Twitter. I do blog, but mostly about R. So for Prometheus users, what is this R thing? So R is actually a programming language. It was originally written by statisticians for statisticians, but as sort of the data science community has exploded in the last 10 years, R has become a much-loved tool in that ecosystem. It's not hard to see why. It's a highly dynamic, interactive environment with tons of built-in and add-on tools for working with data, doing visualization, doing modeling, and so on. A unique thing about R is that it's mostly used by non-programmers. Particularly, it was super popular in academia, and most people who write R code are not primarily R programmers. It just is the way that they do their job. As a result of this, there's like way less of an engineering culture in the R ecosystem. So in most mainstream languages, the reality is most people who write in these languages are developers or engineers, whereas that is not even remotely the case for R users. And in addition to this, until very recently, there were not a lot of stories about using R in production. That's changed. But it does mean that you can basically find an R package for every statistical method you could possibly imagine. Most statistical methods, as they are published, come with accompanying R code. There's also tons of support for doing anything you can possibly imagine with LaTeX or scientific publications, but it does mean that the sort of production-oriented packages can be lacking. And in particular, there was no R client for Prometheus until I wrote one. So if you're an R user, you can get this today. It's in the official R package repository. Now, for R users, what's actually the attraction of Prometheus? So mostly this is because R does not have a long history of being used to write applications, but this is actually changing and pretty fast. So while R was really being picked up as a data science application, it suddenly became popular to write applications because of 2 new frameworks called Shiny and Plumber, which are for writing web apps and for writing RESTful APIs. As a result of this, like tons of new semi-production, internal, or kind of production, or even forward-facing, client-facing production apps are now getting written in R. Often embedded in larger organizations where R is not the primary programming language. So R has, unfortunately, a history of operating in the quote-unquote shadow IT space, which means it's not an officially supported tool, but people are using it anyway. As a result, lots of R users are doing administrative or DevOps related work in order to actually get their job done and use the tool that they want to use. And it does create this awkward dynamic where operational folks, like many of you here who are using tools like Prometheus, kind of have to get our users to opt in order for them to be able to use these tools or platforms. So for me, I really wanted to make it easy for our users to do this opting in. And that primarily means that you should get good default out-of-the-box metrics for these popular frameworks in like one line of code. And actually, there's a precedent for this. I was inspired by existing Prometheus clients in the ecosystem, particularly the .NET client, which gives you sort of ASP.NET support in 1 or 2 lines of code. So that's all the time I have, but I will say if you have our users in your organization and you want them to be able to talk to things like Prometheus, consider pointing them towards this project. Thanks.
Okay, thank you. One quick note that the Prometheus format and open-metric formats are 2 different things. They look pretty similar, but they are different. That's a common confusion, unfortunately. So our final talk then of the conference is by Jeremy Banzaf on lung cancer and Prometheus.
And today I'm going to talk about how to use Prometheus to lower your risk of lung cancer. So a little bit about me. I've been in Norway since 2010. I love metrics. I bought a house in 2015, and it was tested to be safe from radon. But ever since Corona started and I've been working from home, I've been a little bit worried about radon levels. So I decided to do some research. Radon is a naturally occurring gas with a half-life of only 2 to 4 days. When it decays, it gives off an alpha particle, which is a type of ionizing radiation. It's not very dangerous. It can be stopped by a wall or a little bit of air or even your skin. But if it were to decay in your lungs and give off a particle there, then that alpha particle can hit some DNA and increase your risk of cancer. In fact, after smoking, radon is the highest cause of cancer among adults in the US and EU, up to 41,000 deaths per year. Because radon is continuously being produced, you'll find it pretty much everywhere you go. Outside it's generally okay, but inside it can really build up. I wanted to find a good sensor, so I did some searching online. I found something that looked great. It's about the size of a smoke detector, designed in Norway, and has sensors for radon, carbon dioxide, temperature, humidity, pressure, and volatile organic compounds. It runs over a year on just 2 AA's, and it's really easy to set up. You just connect it to your smartphone over Bluetooth, and it'll automatically download that data and upload it to the cloud. I didn't want that though. It's my data, why should it be in someone else's cloud? And besides, I wanted to play with it. Fortunately, a little more searching brought me to the WavePlus reader, which is a free script that the AirThings people made. It's really easy to set up with a Raspberry Pi, and it uses the MIT license. So I decided to make an exporter. It was really easy. I just imported the Prometheus client, added some gauges, and started the HTTP server. In fact, all of my changes you can see on this slide right here. Once I had my exporter running, I wanted to get my data into my own cloud. The diagram looks a little bit complex, but actually all the config is also right here on this slide. Next, I wanted to build a graph. It's really important that graphs should tell stories. Starting with the basics, you always want to label your axes, start at 0, and keep things as simple as possible. Here's the first graph I came up with, and it's really pretty awful. There's no labels, the legend is illegible, and I have no idea if these numbers are good or bad. Here you can see I've added labels, so at least we know this is a graph of carbon dioxide at parts per million over time. But it's only when I add thresholds that this graph really starts to sing. We can see now that when I'm in my room with the windows closed, I'm always in the bad zone of carbon dioxide. And at these levels, the carbon dioxide affects my ability to think and make decisions, which means that I was not at my best during these meetings. I needed to open a window. But back to the radon. Using the graph, it's easy to see that radon levels change a lot over time. Even during the course of a day, it can go from quite high, over 200 becquerels per cubic meter, to under 100, which is fairly safe. This confirmed that I really should do something to drop my risk of getting cancer. I got 2 old case fans and some ancient power supplies, and attached them to a flexible duct. I put the intake on the floor of the room, and the exhaust out in a hole in the wall to the world. My results were great. When I turned on the fans, I saw the radon level gradually drop. This continued over time, and I've got it running right now. Of course, there's always more to do. I wired up a Raspberry Pi to control a wireless outlet, and I set up a cron job to query Prometheus. see if the levels are too high, and based on that result, turn on my fan for an hour. In conclusion, stay safe. Take walks, open your windows, and I strongly recommend getting a radon sensor. Please feel free to use my exporter, and I'll be grateful for any improvements you can give. Thanks a lot.
3 more people who should be switching on their cameras and waving into...
No, they shouldn't.
Oh, yes, they should.
No. You need to show up.
Anywho, so that was the formal part of PromCon online, and we somehow made it work, and it was weird and strange, and we'll learn from this, and we'll post-mortem this, and we'll probably also make the post-mortem public, because open is always better. It was super nice to have everyone here, and there's a lot of people who are not currently on the screen who also did work behind the scene or in front of the scenes. Thank you a lot to everyone. Thank you a lot, and hopefully see you maybe this year, most certainly next year. And stay safe and see you in the breakout sessions.